Welcome to half-angle formulas. First we'll look at the half-angle formula for the sine. As you can see, it says sine of a over 2 equals plus or minus square root of 1 minus cosine a over 2, where the plus or minus depends on the quadrant. In other words, very important point here. You know how when you have the quadratic formula and you have that plus or minus and you know it means that you have two answers? No, you do not have two answers. It will be one of these. And you'll have to analyze the problem based on the quadrant to determine which of the two it will be. Now, I would like to point out that this little phrase here where plus or minus depends on the quadrant, that's only if we're in the context of a Cartesian coordinate system. In other words, if you have a problem, that's placed in the xy axis, such as a unit circle, then you would have to determine this. If you're just dealing with pure geometry, such as a triangle which has been drawn, then you won't have to worry about it. It will just be positive. Don't worry, I'll do an example of both of these for you. So here's our first example that we'll analyze. We're going to use the figure below to find the sine of theta over 2. Notice that's a half angle, half a theta. I've reproduced the formula for you, and let's have a look at the figure. All right, now this figure has nothing to do with the Cartesian coordinate system. It's just a generic triangle. So for this problem here, we won't have to worry about the plus or minus. It's just going to be positive. So we can ignore that this first time around. Anyway, so the formula will be that the sine of, well, here in this example our angle is theta, so the sine of theta over 2 equals the square root of 1 minus, now we'll have the cosine there, of theta over 2. So notice we have a little side problem to work out, which is what's the cosine of theta? Well, fortunately, we can do that easily with right triangle trigonometry, the old SOHCAHTOA acronym. SOHCAHTOA, C-A-H, says cosine is the adjacent over the hypotenuse. So here's our angle, theta. Cosine of theta equals the adjacent, which would be the 4, over the hypotenuse, which of course is 5. So all we have to do is plug 4 over 5 into our radical here, and then of course do a little bit of simplification on that. Now there are multiple ways of doing the simplification. I'm going to show you what I think is an easy way to do it, but you certainly could choose a different method. What's really bad about that fraction is it's a complex fraction. It's that pesky little 5 there underneath the 4. And we can easily eliminate that by simply multiplying by each of the 3 terms in that fraction by the 5. See, let me first do it here with the 4/5. If I multiply by 5, those 5s will cancel. You see, that'll be very nice. But you can only do that if you also multiply the 1 by the 5 and the 2 here by the 5. Let's carry through with this. We now have the square root, and 5 times 1 is 5. The fraction turned into a 4, and then we have 10 underneath, and so that's the square root of 1/10. The square root of 1 can be taken. The square root of 1 is just 1. Square root of 10 can't be taken. It can be approximated with the calculator. But let's work with exact answers. So let's now go and rationalize the denominator here by multiplying the radical on the bottom. And this will give the square root of 10. And the bottom, square root of 10 times square root of 10 is 10. That would be the answer, exact answer, where the denominator has been rationalized. Here, instead of the sine, I've given you the half-angle formula for cosine. Probably notice that it's fairly similar to the last formula. In fact, the only real difference is that there's a plus sign in front of cosine of A rather than a minus sign. underneath the radical there. Remember, this plus or minus doesn't mean there's two answers. It means that if it's in a coordinate system, you'll have to determine which one it is. Let's find the cosine of theta over 2, where the tangent of theta equals -4 over 3, and theta is in quadrant 2. I've reproduced the formula for the cosine of a half angle, that is a over 2. And in this case, we certainly are dealing with a specific quadrant here. Theta's in quadrant 2. So we will have to determine whether we want the answer to be positive or negative. Well, since the other details will be a lot like the previous example, let's first focus on getting the correct sign, plus or minus. Here's how you do it. Where it says theta's in quadrant 2, what I want you to do is write on the left and the right hand side the angles. You can just do it in degrees that theta would have to fall in between. Here, look, quadrant 2's over here. So notice quadrant 2 goes from 90 degrees to 180. So that's what I mean. Theta's between 90 and 180 since it's in quadrant 2. You can do this if the problem had said other quadrants. For instance, if it said quadrant 3, then you'd go 180 to 270, quadrant 4, 270 back to 360. Okay? Now, what makes this very helpful is let's take that theta and now divide it by 2. Theta divided by 2 will be in between 45 and 90. What quadrant will that be in? Well, 45 to 90 would be right here in quadrant 1. So if you have a cosine of an angle that's in quadrant 1, is it positive or negative? In quadrant 1, the cosine is always positive. So that tells us for this example it will be a positive. Now let's do the mathematical details to get the actual answer. A little sketch is going to help here. Theta's in quadrant 2. The original theta is in quadrant 2. And so let's draw it in quadrant 2. Make a right triangle. Looking at this angle here. And we are told that the tangent equals -4 over 3. Tangent is opposite. So the opposite has to be 4, and it's over adjacent. That has to be 3. Opposite over adjacent. Let's use the Pythagorean theorem to find the hypotenuse. Oh, just thought of something. Tangent's negative. Which of these two values is negative, the 4 or the 3? Well, since it's in quadrant 2, the 3 is negative. We're going to the left. All right, now using that, the Pythagorean theorem would be as follows. C squared would be 25. So C would equal 5. Our formula, we need to know the cosine of our original angle. So the cosine of theta would be, looking at the illustration, adjacent, -3 over the hypotenuse, which is 5. And now let's do the final bit of work to get our answer using this formula here. Cosine of theta over 2. We determined that it's positive. Be the square root of 1 plus our cosine, which was -3/5. That would be over 2. Showed you a trick in the last example. Let's multiply each of these 3 numbers by 5, which is kind of nice because the 5's cancel then. And we'll have the square root of 5 minus 3 over 2 times 5, 10. Square root of 2/10, which can be reduced to 1/5. Just a little more work to go. In the numerator, the square root of 1 is just 1. Denominator is still square root of 5. And then you can go and rationalize the denominator and you'll get the final answer, square root of 5 over 5. Last thing we'll look at is how to do half-angle formulas for tangent. There are two of them here on the page. Either one can be used. Honestly, it's kind of just a matter of personal preference. I list both of them there. And we're going to use the half-angle formula to find the tangent of 15 degrees. Now, when you look at the unit circle, you know values for 30 degrees, 45 degrees, 60 degrees, larger. You don't have 15 degrees specifically mentioned. The way we can use a half-angle formula to find an exact value is we can think that 15 degrees is half of 30. Okay? What that means then is that in the formula, A would be 30. 30 over 2 in terms of degrees would equal 15. So I'm going to use the first of the two formulas. So I write it out. Tangent of 30 over 2 degrees, which of course will give us what we want. 30 over 2 gives 15, doesn't it? Now let's use the formula for that. It will be 1 minus the cosine of A. Now A is the 30 here. And that's a value that you should already know, cosine of 30 degrees. And the denominator will be the sine of 30 degrees. So let's see. The cosine of 30 degrees is the square root of 3 over 2, and the sine of 30 degrees is 1/2. Let's multiply all three of these by 2. Get some nice cancellations here. And we will have 2 times 1 is 2, minus the square root of 3 over 1, which, well, that would just then be 2 minus the square root of 3. Okay, folks, good luck with this material.